So this is the second method used to solving differentiation, which is called product rule. So as we all know, product has to do with what? Multiplication of two things, or two or more. Understand? But as for differentiation, we are considering two variables. You understand? So let's assume we are given a variable y equal to what? Let's say u v. We're talking about what? Product. So let's say this y is equal to this u. This is u times v. You get it. This is u times v. So this is the product, the multiplication of two of them. You get. So what the product rule is saying is that dy over dx of this function is what? Is u v prime plus v u prime. And in other words, what it simply means is that if you are given two different functions, you can consider calling any of them either u or v. Okay. So if you are given y equal to you given let's say two different. But this is what's it called? Product. Product has to do with two things, two or more. Okay, but in the course of this study, I'm considering only two. You understand? So what it's simply saying is that keep the first one constant, differentiate the other one, then plus keep the second one constant, differentiate the other one. So now, if you watch carefully, this is the y over the x. So if you want to differentiate it, this u means it's not differentiated. That's why you are saying it's on its own. Then this v prime here means the v over the x. You understand? Then differentiate the v with respect to x. You get plus keep that v constant, don't touch it. Differentiate the other one. Let's solve so you get to understand better. Let's say solve for y equal to 2x plus 3 and like I said, you have to do with two things you get. So you can either call the first one u and call the second one v, or call the first one v and call the second one u. Because in maths, 2 times 2, so the 2 times 3 is equal to 6, and 3 times 2 is equal to 6. So the order does not really affect the calculation for product rule. You understand? So now let's assume I'm calling here u, I'm calling here v. So now from the formula, which is this, to get the y over the x on this, which is the y over the x, simply keep this u constant, don't touch it. So as this 2x plus 3 is, it's my u. I'll still keep it like that. 2x plus what? 3. I will not touch it. Then multiply it by what? Multiply it by this v prime. This v prime means differentiate this v now with respect to what? X. That's the v over the x. So now, if I want to differentiate this 4x, I've already told you how to differentiate. So to differentiate 4x now, to be what? 4x, remember the power is what? 1. So 1 times 4 is what? 4x, right? Then move 1 from the power, which is 1 minus 1. So 4x raised to the power 0. 4 times what? Anything power 0 is what? 1. So this is another I'm saying what? 4. In other words, anytime you are differentiating a constant and a variable, the answer is the constant and a variable, not a variable used for anything. If you are differentiating 5x, the answer is simply 5. If you are differentiating 4x, the answer is 4, and so on. You understand? So this is times 4. That's the derivative of this function. Then plus what? V. Keep this one constant now, don't touch it. So 4x. Then dot differentiate what? The u, which is this one. So like I said, we have 2x here now. To differentiate it now is what? 2, right? So I'm having only 2. This plus 3 now is plus 0. Plus 3 is a what? It's a constant. So use this 4 to multiply the bracket. So the y by the x equals 4 times 2x is what? 8x plus 4 times 3, 12 plus 4x times 2, 8x. Therefore, dy over dx equals 8x. Now, collect like times. This 8x and this 8x are the same because they have the same variable. So we collect the one that has the same variable and add them together. So 8x plus 8x, 16x plus what? 12. We want to consider the second example. Let's say that y is equal to 2x minus 3 and 5x 3. So for those that don't understand what I said before, I said that product tool, let's assume, okay, let's say product tool has to do with what? Multiplication, right? This is the formula. You understand? And I said the arrangement does not really matter because if I said 3 times 2, it will give me 6, right? And if I said 2 times 3, it will also give me what? 6. So anyone I put first does not really alter the what? The answer. You understand? So now, anytime you are giving a question, something like this now, this is simply representing this. You can either say that this U is this V is this one, or say that this V is this, and this U is this, which what I will just explain does not affect the answer. Do you understand? So now with this, if I now say dy, I'm considering here now to the U, and what? V. If I say dy over what? Dx. And recall, I said from the formula, dy over dx is equal to what? U v prime plus what? V u prime. Whatever the x is equal to u, keep it like that, don't change it. So bring back this function 2x minus 3. Then multiply it by what? V prime. Differentiate the v, which is this. If you differentiate 5x raised to the power 3, 5x raised to the power 3, I said bring down the what? The power 3, right? Times what? 5. Then x raised to the power what? 3 minus what? 1. So I'm having 15x raised to the power 2. So this will be times 15x what? X squared. You understand? Plus, now v, bring down v, don't touch it. Keep it like that. So 5x raised to the power 3 multiplied by what? U prime. Differentiating what? The u, which is this. If you differentiate a variable, like I said, as long as it's a constant, as long as it's a constant attached to a variable that has the power of only 1, the answer is the constant. So here I have what? 2. Recall that if you differentiate a constant on its own, the answer is what? 0. I explained it in, in the first method. So now dy over dx is equal to, use this 15x squared now to multiply out or open the bracket. I'm having 15x squared times 2x. Give me what? 30. This is x squared and this is x. So x squared, 15 times 2 is 30, right? So x squared times x. This is x squared times x on this own has the power of what? 1, right? So indices now. This is multiplication of indices. X, they have the same base. So take the base and add the power. So 2 plus 1. So x is equal to 1. So this will now be x raised to the power 3. You understand? If they are the same base, then add the power. This multiplication of indices. So this is 30 x raised to the power 3 minus 15 times 3 is what? 45. 45x squared plus 2 times 5x cubed. Give me what? 10x cubed. Right? So now 30x cubed. Now collect like times. 30x cubed and 10x cubed. They have the same variable and the same power. So you add 2 of them. 30x cubed plus 10x cubed. Give me what? 40x cubed minus what? 45x squared. Right? So I can say that dy over dx equal to 40s cubed minus 45x squared. But since there is x and there is x, they can still factorize, but it's not really mandatory. When I say factorize, I can factor out what can divide 40 and 45. I think 5 can go, I think 5 can go and go. So if I keep 5 go, 5 can go. So if I make out 5 here, x cubed is here and x squared is here. So I can make out 5x squared. Since x squared is here and x squared is here, but here is x3, which means I'm left with 1x here. I can bring out 5x squared. Open brackets. So 5 divided by 40 is what? 8. So I'm having 8x here. You get 8x then minus 5 into 45 is what? It's 9. So this is simplified form. But anyone can go. You understand? Anyone can go, but this is in case you want to simplify further. Whereby if you open this bracket, you still get back the same thing. If you have any question, please do well to ask your question in the comment. Do well to drop your questions in the comment section, and I will try as much as I can to answer all of them. Thank you.